Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the May 2015 grade 11-12 contest question 16. So the question is, a sequence AK is defined by this, where K is a positive integer and curly brackets denote rounding. For example, in brackets, the square root of K is the nearest integer to square root of K. What is the smallest integer, n, for which the terms form a sequence of 2015 consecutive integers? Alright, now let's see what this last sentence means. Now we know that this term is one bigger than this term is one bigger than this term, and so on. Now for here AK, we would replace the K by n. So we would have an is equal to, and then here again the k gets replaced by n. So we have an is equal to n plus, in brackets, square root of n. Now for the term n plus 1, well that's one bigger, n plus 1 is one bigger than an, and then equals to, then we have, instead of k we have n plus 1, and now that's already one bigger than n. But then we still have the plus in brackets square root of n plus 1, which means that those brackets, that must always be a constant. So whether it's in brackets square root of n or square root of n plus 1, it always stays the same. So now let's write this down. Okay. Now we know that the rounded value, this rounded value is this is equal to this is equal to this, all the way for all 2015 terms. So for these integers, let's call them by different names. So let's use m. So we have m equals 2. Alright. Now for the square root of n to round to m, well, it cannot be less than m minus a half, and it also can't be greater than m plus a half, or else it would round to m plus 1. So now let's write this down. So this is what the interval would look like. And now likewise for the last term, square root of n plus 2014, again, we have the same thing. So we have it can't be less than, again, it can't be less than minus 1/2 or greater than m plus half. So we have m minus a half. Alright, now we know that, of course, the square root of n plus 2014 is greater than the square root of n. So if we know that the square root of n is greater than or equals to m minus a half, and that's satisfied, well then we don't have to worry about the square root of n plus 2014 being greater than or equals to m minus 1/2. So now we can just erase that. Alright, and now if we know that the square root of n plus 2014 is smaller than or equals to m plus a half, and we know that that's satisfied, well then we don't have to worry about the square root of n being smaller than or equals to m plus a half. So we can erase this too. Alright, and this. Okay. Now here we're dealing with square root of n, square root of n plus 1014, so we want to get rid of the square root. So we'll square both sides. So we have n minus 1/2 in brackets squared. Well, that will give us m squared. And then we have minus 2 times that is, well, 1, so we have just m. And then we have this squared is then plus 1/4. And now we would still have smaller than or equals to n. Because, well, we don't have to write negative n because we know n is positive. And also m squared, m minus 1/2 is positive, so therefore the sign will stay the same. Now over here, again, we want to square both sides. So we'll have n plus 2014 now we have n squared plus m and then plus 1/4, and again the sign would stay the same. Alright, now over here we can get rid of 1/4 and then we would just have m squared minus m. But now when we get rid of this quarter, we know that the left hand side gets smaller. So if this was already less than n, well then it will just be even more or less than that, and then of course that sign will still be there, the less than. But now if it was equal to n, well, taking away 1/4, then we know that again it would be smaller. So now we are left with m squared minus m is smaller than n, less than n. Now over here, when we get rid of 1/4, well, we know that for these two integers, we have m plus 2014 and m squared plus m. We know that they are both positive integers. So therefore, by taking away 1/4 on this side, this relation does not change at all. So the sign would stay the same. So we would have n plus 2014 is less than or equal to, and then m squared plus m. Alright, now let's add both the left-hand sides and the right-hand sides. Alright, so we have m squared minus m, and we have plus n plus 2014. And now, since we have less than or equal to, when you add both, well then you are left with less than. And then on the right side we have n plus m squared plus n. Alright, now we have m squared and m squared, which will then cancel out. Then we have n and n, which will cancel out. And then if we bring the m's on this right side, then we have m, well, plus this m is 2m over here, and still 2014. And that is then less than 2m. And dividing by 2 on both sides, we're left with 1007 is then less than m. Alright, now since n is bound from below by this relation, we are now looking for the smallest value of m. And now this is just 1 greater than 1007. Well, that is 1008. Alright, and now finding the smallest value of n, well, this is equal to, and now we would just bring down this. So we have m squared minus m, well, Actually, here's the correction. There, we would bring down that. So we have m squared minus m, which can also be written as m times n minus 1. And now it would just be 1 greater, plus 1. So this is equal to 1008 times 1007, and then just plus 1. Okay. Now we'll do 1000 times 1008, which is just adding 3 zeros at the end. Okay, and then we have 7 times 1008. Well, 7 times 8 is 56. And then we just have 7 times 1000 is 7000. So we have this plus that, and of course, plus 1. And that gives us, well, here we have 7, 5, 0, and now we have 8 plus 7 is 15, 5, carry the 1, now we have 1, 0, 1. So our end result is 1015057. Now the key to solving this problem was seeing that these rounded values are all one and the same integer throughout all 2015 terms. And then also finding a new name for that, which in our question here we used the variable m. If you'd like to know more about this contest, please feel free to visit our website at cariboutests.com.